Papa Bale. I think it's really cool that it can move like that without any power going through it. I mean, seriously, it's only run, this part is only running on 2 directional rectifier diodes and a reed switch. That's pretty much it. But I'm about to turn on like phase 2. It's a double NPN circuit. And it basically does an X. All right, so these 2 coils right here are connected to these 2 coils back here via the 20 gauge. And then the 2 28 gauge strands that are back here are connected to the bridge rectifier, which is in turn connected to the super caps. So when I turn this on, we're definitely going to be charging the super caps, because every time that 20 gauge strand gets a jolt of electricity through it, it's going to touch the 28 gauge strand that's wrapped up with it, because they're bifilar coils. I mean, you know how that works, right? The closer you are to the wire that's got electricity going through it, the more that electricity you're going to pick up. And there is lens here. There's tons of it. But as you can see, it's not really affecting it right now. If it gets going slow enough, it'll sync up. I'm going to check this out, and then I'm going to turn it on. All right, I'm going to turn it on. Wow, it feels like it's on. So this is 2 180 circuits hitting. The 180 is what links all this together. So there's 8 coil slots, is 45 degrees on the rotor, and then there's 60 degrees on the stator. And 180 degrees is what, binds everything together. So like if I put 8 on the stator instead of 6, it'd still be 180 that's going to link everything together. Now if I put 4 in the middle, it's still going to be 180 that links everything together. The only ones that would not link together at 180 would be like a 9 magnet rotor or a 7 magnet rotor, a 5 magnet rotor. Like almost all the odd ones wouldn't work. 3 will work, because this is a 60 degree, and 3 would be 120, and it fit in this perfectly. Matter of fact, I have a 120 rotor over there. So what's going on right now is I've got two bifilers and they're linked in series. But each one of those bifilers is linked to itself in series, and in that series connection I have a diode. So there's two diodes and a reed switch. And this is the result of that. I'm like, you can't run something on a diode. You can a little bit. See, now it's lensing. It's starting to lens up. And the more it goes the same direction, the slower it's going to get, because the less that reed switch is going to hit. But the funny thing is, if you try and put any power through it, like even from the caps, if you try to run the caps through the reed switch, lens, you're done. It's over. Then you gotta rewire that, because that's gonna slow you down. And I didn't even figure that out until earlier today. I was still trying to run what was in the caps through the reed switch. I even put like a toggle switch so that I could be in control when that happens. There's not enough energy in those caps to run this thing on a reed switch. And it's 11 volts, 10 farad. But it never gets up that high. There's just not enough being generated at one time to run that. And here, we're going to let it run for a minute, and then I'm going to check how much juice is in those caps. I'll be over there to check the phone in a minute. And that was just a little bit of time there. It's going to be, it might be a volt, probably a little under a volt. But, you know, if you run it for a while, oh, it's 1.6 volts. Nice. That's 1.6 volts at 10 farad. So that's not bad. For how little it was running, that was pretty good, actually, I think. Here, we're going to try and get above 2. I currently don't have anything hooked up to the caps. After being dismayed by the reed switch, I said we're just going to charge up. One more time, and then I'll go over to the phone. Oh man, I'm glad the energy doesn't dissipate very quickly from the cap banks. I mean, it does go down. There is a voltage drop. Today was my brother's birthday, so I was chilling with him. 1.75, so it went up 0.15 of a volt from running that. And that's two caps linked in series. So it's a 5.5 and a 5.5 in series. I think that's awesome. Not like we can really do anything with it right now, but that's almost 2 volts. Hello, hello. Yeah, it is kind of a gyroscope type thing. Hello, hello. So this diode right here, and then there's a diode buried in here. When I go like this, that diode changes whatever's in that wire to DC. It's a rectifier diode, so that's what it does. And then of course the reed switch is going to respond to the DC, however much it is. Because that's what reed switches are good like that. So I just think that's awesome right now. There's no power going through that. And it's moving like, wow. Now it is a mess up there because I had to connect across the entire thing coils. You know, there's literally an X of, you know, the drive coils. Bunch of them hooked together. And it's a 180 circuit, two 180 circuits that make an X. And they'll hit both of them every 180 on the 60. So that's awesome. But if you don't give it a little nudge, it'll lens up. Because all those coils are right next to the magnets, which is good for a lot of things except lens. It's bad for that. You want to have a little bit of depth if you're going to avoid all that. And it stops because it's running off the momentum from my hand. But to get that much motion off of what I just did, there's no way. There's no way, especially with the lens effect in effect. There is no way that, you know, I pushed it through all that with what I did. So cool. So I don't know what is going on out there, but I'm having a blast just spinning this thing just like that. Like, there's no way, but it's doing it. It's doing it on two rectifier diodes and a reed switch. I think that's awesome. And I do recall once a long time ago, a buddy of mine, uh, Hall Effect X, he said you can run it on a diode, and but I was doing I wasn't doing one of these. It was just a motor like this with the magnets on the rotor and the one coil on the outside, and it didn't work. And I was like, okay, but now I see the what he meant. It's more of a flow matrix than it is current or voltage. There's a tiny bit of current and a tiny bit of voltage, but it's more about the direction that it's going and like the flow, how quickly it's going there. Most people would call that the current, but you don't need current for flow. You don't need amps to make something run. But if you want it to spin like and do work, you need power. If you just want to enjoy it and have it spin, you don't really need power. You want to go back to 95? I don't. And I was young then, man. See, these things want to counter rotate. If you make it so the magnets, the permanent magnets, and the electromagnets can spin freely, this thing is going to counter rotate every time. I'm not doing anything here to make it happen. It is doing it on its own. All it needs is power and direction. Heck yeah. So if as long now I had to disconnect. There were two 30 gauge coils on here that when I had them plugged into the caps, and there was like three feeds going into the caps at once. It was so stuck that even with the power it wouldn't turn on, and I was like, yeah, that's lens. So they're just on here for weight and looks. Notice how there's 8 coils and there's one on each section. Two of them are not hooked up at all. And then 2 are hooked to the reed switch and 2 are hooked to one MPN, and 2 are hooked to another MPN, and that makes 8, which is awesome. Now I'm working on making a new base. I've now attempted 2 prints, and with the ABS, they're warping before they're even halfway done. And I'm like, I'm probably just gonna have to splurge on some, something else. I mean, I have a printer that'll do carbon fiber, but it's a smaller printer. I need, the 15-inch plate to make this. And it's like, it spins really, really fast. So I would not build this in sections. I don't think that's smart. There is an increasing, safety factor if you're going to glue your rotor together. I don't care what super glue you're using. All right, so right here is the breadboard with the 2 MPNs. You got 2 halogen bulbs as resistors, and then you got them all hooked up to this distributor that's hooked up to this battery. So when I flip this switch, both MPN circuits will be lit up. So you got that X that's going to hit. See, let's line it up. You're going to hit once here. Whoops. You're going to hit once here. And then this one is right here. So every other one is going to light up. So now this one's going to light up. See, it's lighting up. And this one's going to be off. And that's how it is with those 6 on 8. But if I make this 8, then we'll get 2 on at a time. But the 180 is where it links up, but it only links up once instead of twice. Or it's like on off. It's hard to explain. So now we're spinning it the other way. And with the reed switch, you really shouldn't be able to do that. But since there's no power, since it's all flow, and when I say flow, it's minimal power. Like I just measured the cap and it was at 1.75 volts. We're talking minimal amount of power going through the reed switch circuit. Only what's being generated by the magnets, and then it's being directed by the diodes. And let me go through the composition so you understand that there is power being generated in that circuit. You got 16 gauge and 26 gauge in the one coil, so barely anything's happening there. But it's hooked in series to a 26 gauge and a 32 gauge bifilar coil, and there's a lot more going on there. I love it. So the 2 MPN circuits are virtually the same. You got a 28 gauge trigger on both of them. And then the 20 gauges are hooked to the 180s. And then the two 28 gauges in the back are hooked up to the bridge rectifier, and they charge the caps. Because they are in the same coil as the drive line, you got close proximity generation. But since it's just, let me think here, 400 turns altogether of 28 at this size, you're only going to get a small amount. But it's the same as, hooking up a signal generator to a coil and then running your circuit and putting another coil on top of that coil and seeing how much energy you're getting off of the coil through that relationship. It's cool. These coils look like there's little wheels in them. It's cool. All right, so let me show you my next project. And I know this looks dinky, but we're going to use this. And then these are 32 gauge coils at 3650. They weigh 5.1 ounces. And we're going to have 4 of those. And they're going to be recessed. See how they're back? You can fit another coil right on top of them. That's what we're going to do. What we're trying to do is maximize generation and minimize the lens effect. And then we're going to get a lot more lens with this one than we do with my 120 over here that does this pretty much the same thing. It has the coil recessed, but they're 30 gauge. These are 32. There's going to be a lot more voltage being generated here. And we're working with a reed switch, so we don't need amps. You know? We don't need them. I mean, when I run with power in the battery, of course we're using amps, but we don't need them. I mean, to fill up the caps, we definitely need power. It needs to be, moving fast enough to do that. And it actually, this power generation doesn't have anything to do technically with how fast it's going, just how often it chirps. So every time it chirps, you're going to get a pulse to the cap banks. Who else? And where's the support going to go? I mean, I totally would, but there's no room to put it on the shaft. So I need a longer shaft for that to even be, but yes, this is supposed to have a cover on the whole thing. It's supposed to have another cone on it. Absolutely. I mean, that was the whole idea. And I've just been struggling with getting it in so that I could get the cone on. And then I also want the shaft going up through the middle. So that means the shaft's got to be about this long. So that's 2.5 feet, 3 feet. Yeah, I mean, a lot of people out there just throw around ideas having no idea that, one of their ideas might cost $500, or they just don't care, But I mean, that's just an example. Do you have any idea what that entails? Support. I mean, I don't understand where it would go. And I change this thing so often that it would actually be a bad idea. And who else is building these things? I really want to meet them. I don't understand the question. The purpose for this is preliminary experience. And I would not call this scientific at all because I have to stop it with my finger. Okay, so that means that this isn't really scientific because it's out of my control pretty much. There is a missing factor of control here that I'm working on, sewing up with like things like that, an IR receiver. If we can get it going, and then I can cut the power. Well, I don't know if that's not this one, but if I can cut the power without using my finger, then we can start talking about it. And then like to put a cover on here, it's still the same problem having to stop it. So we need that IR remote. Simplest way, man. I'm not trying to connect this to the board at all. I'm not trying to put a slip ring on here that will allow me to connect it to a power supply. I am not trying to do that. That defeats what this is. Now, if you can find me a slip ring that'll go 750 RPMs rated, I'll consider it. And I mean, if you're going to be a messenger or deliverer of ideas, yeah. No, actually, you're not supposed to run them at the same. It doesn't work that way. You would need an IR remote to turn the gen coils on and off. You can't just run them with the coils on; it won't work. So, like I said, all those are good ideas, but they're going to be run by a remote, and I can turn the brake on and off if I want. That'll be good. We need a flip-flop circuit, I'm pretty sure, so you can turn it on and off. Look at that, man. I mean, that thing has been going since I. That's so cool. Yeah, dude, you really suck at communication. The other guy, I don't know who you're talking about. And it seems as though you're trying to tear it down. You should really, learn how to talk. I mean, what I mean is the value of what you're saying. It's good to have some value in what you're saying, not just saying stuff that is really designed to say, hey, look what I got. You don't have it. So there, haha, that's what you're doing. And if that's not what you're doing, you really need to learn how to talk. All right, Ulysses, I'll give you a quick breakdown. All right, there are two coils dedicated to a reed switch, self-running circuit, and there are two coils dedicated to each NPN circuit, and there's two of those. And all these are at 180. Now there's a 12-volt battery. It's hooked to a distribution module, which then filters into the two NPN circuits. So when I turn it on, both of those NPN circuits are firing. And it's an X, like that. And so each 180 circuit, well, let me just explain. You got the two trigger strands that are 28 in the front, and they're hooked to the NPN circuits. And then you got the two 28s in the back, and they're hooked to the bridge rectifier, which is in turn hooked to the super caps, which we are charging currently. Let me see how much juice is in them. This is the only way that I can really see what's going on in here. Now let's see. Yes, 2.21 or 2.12. So we've moved up from the lowest settings. We're above the 2-volt setting. We're at the 20-volt setting. Awesome. We got overload on 2 settings. That's awesome. So when it's on, those two 28 gauge strands that are linked into the drive coils, because they're all bifilar coils. And then the reed switch one, which I find really interesting, is we've got two bifilers, 16 gauge and 26 gauge, linked together with the rectifier diode. And then we've got the 26 and 32 linked together in a rectifier diode, all hooked to a reed switch. So what happens is more than likely the 32 and the 26 generate a small amount when you spin it, and those rectifiers put it where it needs to go. Hey, Mike. That's why it's not going to go that fast. That's why I stop it with my finger, dude. You know, I just watched a presentation about, and in the presentation, it was disputed that somebody should use C clamps instead of spring clamps. You know that there's two sides to that coin. You know, there's two sides to that story. So this is the reed switch circuit that I was talking about, the one that's running right now. Oh, you're right. Right around 2K RPM, the glue is going to let go and stuff is going to fly. Stuff is going to start flying off this thing. And that, you know, I'm not a dummy. Just because you want to see it go that fast doesn't mean I do. You know, put your money where your mouth is, bro. And it would be cheap, probably. It sounds like it's not expensive to do. I'm not a carpenter or an engineer, dude. I'm neither of those. I'm not a machinist. I don't know how to do a CNC machine. I could probably learn, but and I mean that's cool. That's cool. But I mean, yeah. I mean, if you see something that it needs, why don't you just, you know, like I said, put your money where your mouth is. Now there is lens on this. See, that's how I know that there's some motion going on here, because once it gets slow enough, you'll see what happens. Oh, you see it cogging now. Saw it. Wow, they both stopped at the same time. That's the first time I've ever seen that happen. That is cool. Now that reed switch definitely sounds a lot stronger when I spin it, counter rotate it. I haven't actually timed it. I just because I just figured this out tonight, like earlier today. It's night, either way I look at it. So yeah, I should probably time it. So you're talking about a smart controller, Mike? like a control speed controller or a controller of some kind. Oh, you bought it. All right, man. Okay, that's cool. That's so cool, man. So, or have you hooked it up to any of your stuff? I mean, you did get it to. Oh, you're just saving money. You're saving money. That's what you're doing. That's awesome, man. It's a good idea. Power, money, kind of the same thing. Hell yeah, that's way better. I could probably run it with this thing. Yeah, and the diodes that are making this thing do what it does, I just put in here before I turned the live on. So, I mean, based on one that I did earlier, um, I kind of based it off of that, and it, I did it with and without the diodes with the self runner, and it um, works way better with the diodes, even though there's a bridge rectifier. So even though there's a bridge rectifier here, these diodes need to be here for it to work the way it does. Yeah. Well, I mean, that sounds like something I might be into is get a little PC or, well, I don't even know whether I need a PC or a microcontroller. Because, if I could just control how fast this thing is going to begin with a remote. And I'm only worried about it when the power's on, because when it's like this, it's a slow, steady spin. Nothing to worry about. I do kind of want to make a covering for this so the things don't just fly away. Not really a support, but just like a casing. You know what? I think I have something like that. I don't know if this one will fit. Yeah, that's not going to fit with all this stuff. I bet I could move it around maybe. No. See, there's some of these things that are glued in, they're just sticking out. Man, I have to really rearrange this. But it's designed to have every 90 degrees and just rest on the coils. And you got to keep it within that 8-inch range or it's not going to fit inside the stator. Mike, what are you doing, man? That's funny. All right, everybody, get yourself a little mini PC. I think I might get myself one. Why? Because I like shiny. And I already got, the 3090 like 2 years ago, and now it's up to like the 5000 series for the NVIDIAs or something, or is it 4000? I think it's 5000. I don't know. I stopped looking after I got my 3090. And yeah, that computer is probably the biggest bill I have in electricity in the whole house. And then my other computer is probably the second biggest drain, next to the refrigerator and the air conditioner, which is going to turn on in a moment. It's going to be a while, but still going to go on eventually. Sounds like a clutch of crickets, man. Axial is a little different. I got a few axial motors like this, but it's a little different. So you can't just throw it out there like that because it's a little different. And basically what happens is you take this outer part and you put it on top, and you have your coils facing up, and then the top goes like this and the bottom goes like that. And maybe you can combine them. I mean, I don't know as of right now if you could do that, or if it would be of any benefit. As long as that thing can plug into my monitor, I'm good. If it can run my monitor, that's good. It's a 42-inch Predator, so it's got to have not the DVI, that's old school, but the display cable outlet. And you see, I don't know if that counts, but I think that counts as no. See now, okay. Now I think it's gonna lens up. This is what I've been waiting to show you, is that this is still got all that property to it, but I've managed to sneak past it a little bit. See, it's all lensing up now. And if those 30 gauge coils were hooked to the bridge rectifier and in turn hooked to the caps, it would sync up like almost immediately, just for having those two coils hooked up. Like it would be like a magnet. So to spin it the other way. Let's see what happens. Oh, I agree. You have like too much dust or smoke in your house, and that's gonna be one of your first problems. Actually, computers these days are built pretty well, but or a short circuit on your fan, but that's less likely than it just wearing out. Or maybe it's the same likeliness. I don't know. I have a bunch of spare fans because I hijacked the CPU or no power supply. Hijacked the power supply and I was running computer fans with a bunch of magnets on them. 1,000 RPMs. And I had this literally like this box of wire, and it was like a big copper fence around the fans with all the magnets on them. So the magnets were in the middle spinning on these fans, and you didn't get much because the magnets were tiny and they were glued on there, and it wasn't much, but you could see it happening. And it was one of the first experiments I did generating electricity like that. Computer fans are fun. It's like the fourth pin or something like that, and you can just plug it in and plug a little paper clip in there. You can trick it into making it think it's plugged in, because there's a safety mechanism in most computer power supplies. See, now that was the wrong way. That's diode opposed. We spun it that way, and it lensed up within like 3 minutes. Society, how's it going? So it's my brother's birthday today, so I haven't been able to do much. That's why I'm on so late tonight. I don't. Fuck the end game. I don't care about the end game. I have no answer for you. This is going to change probably 100 more times before it gets anywhere near being done. So there is no purpose or goal to achieve. It's right now all it's doing is charging supercaps. we'll go from there. We're going to run it a few times and then I'll check the caps. Yeah, I could really use that. Normally I just use tape. Anyway, let's check them. Almost 2.5 volts. So 2.43. And right now there's no escape for it. So it's going to be stuck in those caps until I decide what I'm going to do with that energy. So all of you looking to hear that I'm doing a time machine or all that funny stuff, man, this is a toy. Look at the landscape here, man. This is for like my enjoyment and I'm sharing it with you. That's what this is. Now, in principle, it's a lot more than that. Use your imagination. Yeah, and there's all that when big ideas happen to dumb people. Call me dumb to my face. Watch what happens. I mean, that's a dumb response, but I mean, seriously, man, you do not know me if that's what you think. No, that's a damn shame. We're having such a good night. I've been up like all day and all I saw was the F word, and I'm like, okay, see ya. Might have been something good. I don't even know. I'm tired. That's all I know. And all I would say to that is, did anybody call me dumb? If that never happened, then there is no implication. So let it go. All right, one more go, and then we'll test them one more time. I knew that was coming. I'm glad I'm on top of my game for being as tired as I am. All right, let's do this. So this is across two caps. 2.67. Awesome. So it's going up every time. I'll do like an overnight test to see how much juice is in the caps when I get up. Oh man. All right, enough about the fucking PCs. Yeah, I'm fucking pissed. Thank you very much. I do appreciate that. I will be right back. shame we're having a good night. There's always somebody out there that fucking thinks, no shit. All right, I got my black light. I'm going to show you guys some things real quick. I don't just do electronics. That's pretty sweet. I love that, man. It's got the black light paint in it, so you got your Gumby guy just chilling in there, kind of blending in with the background. Pretty sweet. Get this back here. Yeah, look at that. I love that. Yeah. Bob, what do you mean? Don't split the core. You telling me I shouldn't do electronics and art? I know I shouldn't make art videos on my electronics channel. I learned the hard way about that. Awesome. I got hundreds of those, man. I got lots and lots of paintings. Even my first schematic I painted. That's so neat. Now what we could use is probably some of that black light paint and just throw some paint on this thing, man. Make it look brighter. Or maybe get some glow in the dark PLA. It might. It might spin for free, but as far as I know, V-Gate is a very specific spread. I don't know how scalable it really is. I mean, I've seen little ones, I've seen big ones, but is this Could it work here? I don't know, maybe. Now see, there's a lot of lens happening here. So I'm going to show you one more thing. It's a totally different rotor. So let me get that. Now this one is weird. What I come up with on this one is strange. But there's 6 coils on this. I'll explain this circuit. You want me to put the other light back in? Because that's kind of dim. Can you see it? It's a counter rotating DC. This one's a self runner. So I just put that in there. Okay, so let me get the light because I need to be able to see so I can explain it. Okay. So you got your bridge rectifier right here, which is got AC and DC caps, and then 4 bridge rectifiers. So it takes AC in, smooths it out, sends it through the rectifiers, smooths it out through the DC, and it's all instantaneous. So it's great. There's no like cap dump thing going on. It's all just okay. So out the side, out the back here, the voltage side, the DC side. Um, you've got 26 gauge. Anyway, you got the 3 coils and they're bifilers. You got all the 26 gauge hooked together in series, and then you've got on the end of that all the 32 gauge hooked in series. So you got one long strand that takes next to nothing to run. Really doesn't need any amps. You know what I mean? 32 gauge is good for this. And then, okay, so it goes through a cap to start the sequence. And then it goes through 1 reed switch. Then it goes through 3 directional rectifiers to another reed switch. And then it goes out a cap and then connects to ground or the negative of the voltage. That's weird, right? I mean, why? I'm like, I don't know, but it was set up a different way before, and I just decided to, instead of rip it all apart, work with it the way it was. So let me think here. Now behind that mess of coils that I described earlier, there are three 30 gauge coils. Everything weighs 5 ounces. It's amazing how they all weigh the same. I would only load down with power. If I had power, then I'd add a load to make it run better. And I mean, in my other rotor, the load is my super caps, but I'm not. Once they get full, I mean, what do we do then? Unplug them? That's not, we're trying not to do that. We want to plug something else into them so that they draw the energy out. So maybe a PNP circuit. Rip off those two 30 gauge coils and put another 180 drive on a PNP circuit. But then, of course, you'll have another buttload of clips and other stuff on top of there. Now, as soon as I figure out what I want to finalize, then I'll make a PCB board. And I will bust out my soldering stuff and I will learn how to do that. But as long as I need to make changes, like, and I feel like it's not worth, putting all that solidity into it, making it a final product, then I'm not going to just do that when I know I'm going to change it again. But doesn't that work nice with all those reed switches and caps and stuff? I think those caps really, really help a lot. I don't know why I think that. I just do. Oh, it's a counter rotating brushless DC motor. And this is its power supply right now. Well, the coils that are connected to it, you see you got this end coming out. They're connected to the 30 gauge coils. One of them's actually broken. So there's only two and they're hooked up parallel to the bridge rectifier. There is not enough energy going into this to make the lights light up the way they normally would. Wow. Everything's like spinning. That's crazy. I guess if you look at these too long in the right kind of light. All right. This is where I would stop it. My timer. Now, I did do a test running a 26 gauge strand, a 32 gauge strand, and then both strands at the same time, and they both ended up to be about 5.5 minutes run time. That's with this one. But now it's a totally different story. I've got the 26 and the 32 on the same line. And I think we're going to blow 530 out of the water. Because you really don't have to generate that much to make this function. And literally, those 32 gauge coils only generate about a volt or a volt and a half. And right now, it's continuously being discharged. But what I'm wondering now is if it's discharging slower than it's going in. Because 32 gauge at that length, that's 3 coils of 32 gauge. So that's 730 turns times 3 of 32. Same with the 26. So that's a lot of wire. But the 2 reed switches, I'm like, wow. Because I, like I said, I did the 26 and the 32 parallel, which means I would need 2 reed switches. That's basically what that's from. And then I got 3 rectifier diodes connected in series, which I taught. I'm just doing that so all that would connect together. You know, I'm using it as a bridge, basically, a directional bridge, bridging 2 clips together. And then I got a cap. See, what I want to do is I want to get a little bit of energy in there, and then I want to create an oscillator with like a cap on one end and then a cap on the other, and then just through the reed switch, it would throw the energy back and forth. That's kind of what I wanted to have happen here, but I don't know. Maybe if I just turn one of those caps around, it would change everything. Let's see what people have to say about that. This rotor doesn't make energy, but it's about 1.5 volts. There are 2 coils recessed that are generating energy for this cat bank, which is a bridge rectifier. So it generates 1.5 volts to 2 volts, and it consumes it immediately. Now, see, I'd be so dismayed if my goal was to make it run forever, but it's not, so I'm happy. I'm listening to those 2 reed switches chirp like crickets, man. That's awesome. That's true. Whenever I hook or turn on the circuit, the rotor does slow, but it only slows to the tune of 1.5 volts or 2 volts. More less, it's way too. It's overcome. The lens effect is overcome. At least for the initial. As you can see, it's constantly slowing down due to that effect you're talking about. But my goal is not to overcome that effect. Never was. Because it's like, like defeating yourself, chasing the dragon. It's like there is no way to beat that. What you do is you mitigate it. I see, and I see what people are trying to do. If you could just do this, it'll go forever. I don't believe it. I never will until it actually happens, and I will never see that happen because I will never live forever. So I mean, like, it's a moot point to me. And does that mean that I lack ambition? I build these things. Of course it doesn't mean that I lack ambition, man. I would not show this to the public if I wasn't ambitious. Cause I get so much flack on this that, it's like I don't know what to say half the time. It's like, wow, no comment. That's how I'm gonna deal. That's how I'm gonna deal with it, man. No comment. Even if it's a what this, no comment, dude. Especially if it's what this, man. I mean, Jesus. I'll let somebody else deal with that. I don't even. And what it is a counter rotate. This is a self runner counter rotating DC pulse motor. I'm going to take that rotor off in a second and go back to the power. But I mean, just this. And it pissed me off because the end broke on the third coil. I bet this would be working so much better just based on the proximity from the magnets of the coils that are generating the electricity. See, I can just touch this and it will go against, it will counter rotate, negating all of that damage, pretty much. See, right here, it's now caught up. It still wants to go, but it's going to catch up. Wow, it is just the little engine that could. And yeah, speaking of a hill, this wobble might create an anomaly. Actually, I've been wondering about that since it's like orbital. It's orbital. It's wobbly. So like some of the magnets are higher and then some of the magnets are lower at different times. Now look at the stator. That's functionality. That works. That's working. So when you're doing self runner, the stator and the rotor, they both count as motion. Now this one has both self-running circuit and two MPN circuits. This one generates power. This one stores power in supercaps. This one needs to be confined. I think I'm going to put duct tape on it. Yes, the Utron base print is uneven. The center hole doesn't line up. I mean, there is a lot of stuff that is wrong with it. And if you look down here, you can see the wobble like quite a bit just based on that magnet. And I don't think the magnet's even. Now you can see the lens on this. It was pulling the rotor almost immediately. And that's because all the coils are right up on the magnets. Now if you're going to put your coil close to the magnet and you're going to try and draw energy from it, you're going to lens. You're probably going to lens to death. You got to have that coil's worth of space between the generator coil and the magnet. You have to have space. There's no way you're going to win. You have to have space. I've tried like literally 1,000 different things to try and beat it. It's like the more you try and draw from it and have it be close, like to get those lights to light up, that's bad. You don't want that. Because it's not a wind turbine, okay? You don't want that. Yeah, I think we're gonna have to just like not run it like that, because all this stuff is looking to fly right off as of right now. And when I found out that when I actually had power for the reed switch circuit, I was using the cap banks and it was just charging directly into the reed switch circuit. Lensed up, like just froze up. I'm like, why is that happening? It's almost like it was a brake. And I did use it as a brake when I was operating with it. When I turned both on and then I ran it, it would run slower. I was like, why is that happening? Anyway, I disconnected it, and then I hooked the two rectifiers. Now there's 32 gauge, 26 gauge, and 16 gauge in that circuit. And I'm thinking that in between each rectifier, whatever energy, be it microvolts, that's definitely what's being generated in that. It's all being, pushed or directionally modified by the rectifiers and changed to DC. So it's going to hit the reed switch, whatever amount it is. And you want it to be low. You want it to be low. And that's what the whole powering the reed switch is not going to work, because you want it to be a low value of energy, not even any stored capacitance. You don't want that. Well, I can't say that necessarily. If it's on the main drive line, yeah, you can hook a cap in series on your drive line, and that won't hurt it at all. It'll probably help it. But you can't draw like a power supply and have it function. I still can't really, I guess it's lens. It's got to be something like that. And you would think that, well, no, man, just your reed switch and it's supposed to go the other way. Well, I tried it both ways. Now, can I say that it's a minuscule? Actually, no, it's pretty substantial. As long as you got the directions right for your diodes, diodes help this self-running stuff out a lot. Like, unbelievable. With and without a diode, you're going to want a diode every time. So I figured out basically why the generation level is so low. That's because these pegs here are plastic. Now, if we had like a core, like if I could arrange it so that there were an inch by an inch, uh, stock of core, or make perfed core with like lots of rods or whatever. But make the rotor here instead of with pegs, make it with holes, and then that would increase generation by a lot. But I think also it would cause a great deal of like magnetic coupling. So I don't know if that would work. I know that it would generate more, and I know that you'd probably get more magnetic flux on the drive. But I don't know if that's necessarily what you're gonna want. It depends on what your goals are. If you want to generate a bunch of electricity, yeah, you're gonna want a core. But if you're satisfied with what you're generating, which is not very much, it was like 2.5, 2.6 volts after running it like 7 times. Total run time probably 5 minutes, maybe. So that's not a lot of energy, but that is definitely energy being, you know, stored in the caps. And you know what? Mm. This is the where the power's coming from. Oh yeah, that is. See, I'm wondering if I could loop it, but I think that'll just stop it like that. Right now, it's hooked up to the switch, and the switch is not connected to anything. So really, it's in between each diode and the reed switch, because there's an open-ended line here. And let's see about and then the other end of the reed switch. got an idea. And I think it's gonna stop. I don't think it's gonna work, but I'm gonna try it anyway if I can find a clip. That's funny. All these clips on everything and I can't find a clip. Nice. Always have a few lying around somewhere. Okay, so we're going to take the other end of the switch. And we are going to connect it to the other end of the reed switch. And then we're going to turn on the switch. Wow, that's pretty cool. Because literally, I mean, I think it's worse, honestly, than what I had before, but I think honestly there's something going on there now. Because what I have is I've got the everything, and then it's like the switch is connected to the front of the main coil, and then the ass end of the reed switch. So that's a loop. Now that's interesting. It's going incredibly slow, but it's continuing to move. I don't know how long it's going to do that for. I'm going to try spinning the stator a little bit faster. So now that it's looped, I think it's actually lensing more, like I said, where it was just kind of trapped in between the diodes and the reed switch. But the reed switch wasn't connected to anything, so that doesn't work, does it? So it was, I don't know why I came up with that, but it was what allowed it to move the most with this setup. Now the other rotor, it works a lot better because it has its own power supply. This one is actually using the coils in the circuit for its power, which isn't working very well, is it? All right, but let's try this. With it hooked up the way it is, I think I'm going to be able to just watch it Oh, that's right. Everything's gonna fly off. I totally forgot. That would have sucked. Oh man. And it looked like it was gonna, just be fast. It was an interesting concept. And it works better when it's not hooked up, when there's like no power going through it at all. That's not self-running. This is more self-running than what I was showing you earlier. But the other rotor, that's what it's designed for. This is actually designed to run with power and charge, capacitors and stuff. But you get a lot less motion with it all hooked up, though. But I think it's more real, more what's really happening. I got an idea that might mitigate what's going on a little bit. That's to use another diode. I mean, we try this. Oh, there's a big one. Here's the big one. Okay, this one goes for 3 amps, 1000 volts. So I put that on the other end of the reed switch. I think it's working better already. Holy cow. Wow. See, so much different with just a diode, man. It's amazing. Uh, they're just plastic connectors. So I feel good about this one, and I think we might move to PCB, um, octagonal PCB. Make it, get the MPNs in there, get the power distributor on there, get the caps on there, the bridge rectifier on there, and then maybe, I don't know, maybe print another one with a little bit of a hollowness in there and put the battery on the inside. But have the room for the second battery, which is basically just a counterweight. I'm gonna have to get some time readings. The ones in the middle are electromagnets, and the ones on the outside are permanent magnets. Heck yeah, man. I mean, wow, dude. And all I did was put it on the butt end of the reed switch in the circuit, which I think there was some oscillation going on with the lens effect or whatever the effect was. And this took care of it. Putting the diode there changed all that. Because I know that oscillation is not the way to get this to work, unless it's between two caps. Because if it goes, like I was explaining earlier, how I wanted to make the caps have it throw it back and forth. But as we saw here, I made it DC, and it worked better than it did without the DC. Now let's turn off the switch. That was with the whole thing on. Now I'm glad I put it in the switch. This is with the switch off. And this is like putting I think it's putting, oh, it's after the reed switch. The switch is after the reed switch and before the reed switch. It's the loop connectors. That's awesome. To actually connect the loop with the switch. That's cool. But there is a break in the line now. And this is running strictly on the power generated by the coils in the circuit, and it's using diodes, and it's broken. The circuit is open. I think that's like cogging, isn't it? I did it a little bit once I turned it on. Wow. Man, learned so much in the night. Yeah, the momentum from my hand, but I always gauge on how much extension, what do I want to call it? The momentum from my hand without any connections whatsoever versus the momentum from my hand with all the connections. Which one is greater? They are in slots. So they're big. They're twice the size of what you see. And there's supposed to be a conal lid that would, hug these, like fit right on top. And it should, I built one like that. It closed right on top of it. And then I would, run it like a pulse motor. It only had 4 magnets in it, but it was an 8-inch Utron. It got going really fast. Oh. Uh, yeah, I mean, I learned about 3D printing in the last year or so, maybe 2 years. And that was half the battle. And then Hall Effect X and Mike does, and I learned how to make coils just from listening to them. And then, the rules and all that. I believe that most of these are south-oriented coils. But since they were wrapped at different times, I do believe that I wrapped some of them counterclockwise. So there would be north-oriented coils. I always tried to make the beginning of the coil the positive end of the coil. You got to mark it with tape or you're going to lose it. I mean, you can like yank on it to make, find out which wind is what, because the end will unwrap a little bit and the beginning will remain stationary. It's going to be pinned in there from all the wraps. But yeah, getting all your coils to face the same way, good, important for generation, and also important for drive. I mean, it is. You don't want to flip flop them. You really don't, because I mean, there may be a motor out there that works like that, but that's not what this is. That's not. You want to have them all facing the same direction, and you want to have them, if they're going to be hooked in series, you want the end to be connected to the beginning of the next one. You connect an end to an end, and you're going to short out, and you're going to get virtually nil, and your reading's going to go down from. Well, what I'm saying is, you'll have the reading of the first coil, then you'll hook it to the second coil. And if you hook it up wrong, it's going to go here. And then if you flip it around to the right way, it's going to give you at least 30 to 50 more volts than the wrong way. It does. It really does. You really need to pay attention to this stuff when you're wrapping the coils. You got to mark it with the tape or you're going to lose it. Or, it's going to not be, it's not going to really be worth it to just be yanking on the strings all the time trying to figure out what's what. But you can do it that way. But I suggest just putting a little piece of electrical tape on there. See, these are 5 ounces of 32 gauge, and this is the beginning of the coil, and this is the end. And they both should be on the same lip here. So the end and the beginning should be on the same, and then when you put it on, it goes on like this, and the far end, the side that the ends are not on, is your front. That's this is the front of your coil right here. If you want it to be the way that you rolled it and set it up, this is the front of your coil. I got to be real gentle with these because they're 32 gauge. If they get caught on anything and I'm like walking away, they're going to break. And lucky me, I'll probably end up breaking the beginning. When you break the beginning, you're fucked. And I had a huge coil all done, man, and it was beautiful. And I took it off the machine and everything was great. And I looked and I was like, my heart sank. I was like, don't be the beginning. Do not be the beginning, because there's nothing you can do. You have to unwrap the whole thing. Start over. And I guarantee you, halfway through unwrapping that thing, everything would have got screwed. Like, even more than what I could throw it away. I couldn't look at it. I couldn't keep it on the shelf anymore. I had to throw it out, and it sucked. Now I'm gonna come over here and look just to see if there's a way to do this that I missed. Yeah, man, it was a struggle. It was a 32 gauge coil too. It weighed about literally 3 pounds, and I made it solely to try and get around 750 on the oscilloscope, and I never got a chance. Oh man! And I started. There was a little tiny, not enough to clip anything on, but there was a little tiny thing, and I tried moving it just to see if it was the. I was desperate at that point, man. It took like, well, I used the machine, the hand rolling machine. About 3-4 hours of just. And when you're winding it like that, you can't really slow down because your spool is going to go woo. So, I don't know. I've gotten much better since then. I take my time. I mean, those are 3,650 turns a piece, the ones that I was just showing you. I take my time, and really the amount of turns is just the counter of my electric machine. So it's got to count some way, right? So it counts in turns. But it's really just a counter mechanism for the machine. It's 5.1 ounces of copper, which has a buttload more inductance than most coils that size. Wow, what time? I don't even know. No, I don't need to use a Hall effect sensor. I'm not even gonna think about it. No. And I don't give a crap about terminology and technical stuff like that, man. I don't care. Sounds like somebody got, and I don't care about that stuff, man. I ended up asking people, what is this? And the people that didn't say a doohickey got my attention. The rednecks that say it's a doohickey, I don't know what to say. I mean, that is just bogue. You don't want to be called names, don't be bogue. And yeah, I get it. Yada, 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 yada. I don't care. Seriously, man. It's not, I'm just trying to show you guys something. If you're going to be freaking anal about it, I hate that shit. It's so backwards. It's backwards as this is backwards as I've done this, man. There's no schematic. I freaking pulled it out of a freaking top hat. And yes, man, it's bogue. Well, I mean, honestly, you shouldn't be correcting me. That's what you shouldn't be doing. Why? Because I don't care. Dude, I really don't. And you're pissing me off. Yes, I'll turn it on. Hello, hello. I gotta tape it all down before I run it. See how everything's starting to push out? I gotta get it all back in. See, but if I put tape on this, people are gonna cry about it. Hello, hello. How we doing? No, it was the fact that, I call this basically a DC brushless motor, and somehow that was wrong. And I'm like, it is a pulse motor, but it uses a trigger strand. It doesn't use a Hall effect sensor. This is a fucking pulse motor. And then I'm seriously, man, if I get like corrected one more freaking time, that person is going to be banned from my channel. I don't need any hot shots fucking telling me what to do, man. It's like, oh my God, what's going on? Maybe I'm just having a psychotic break right now or something. Maybe nothing what I thought is happening at all. I have been up now for 48 hours. I do want to show you guys something that I'm working on though. It has nothing to do with the motor over there. All right, so these are aluminum stock. And I would have this one in the middle, and they'll go around it like that in a pentagonal shape. I got the paper right here. I was going to get agar and potassium chloride, and then maybe the insulation for a diaper, and do what I gotta do, wrap it up in tin foil, and then put some more paper on it. But I've got 3 more bars this size, so I can make 3 of these, 3 more of these. And what I really want to do, I mean, it will be like technically it being a capacitor or a battery of some kind. But I want to hook this up to one of these. I want to have a platform kind of like this with these underneath. Oh man, so yeah, Michael from Faraday Research has been really stoking my curiosity about the batteries and capacitors, stuff like that. Homemade variety. I haven't never soldered a damn thing. That's why. Huh, man. Sorry about like blowing up. You think if I soldered stuff that I would have done that? And since I am changing this literally like 3 times a night just to try and get it the way I want it, why would I solder that? If I'm changing it 3 times a night, why would I solder it? There's no schematic for this. It's not like I have a schematic and I put it together, meticulously using a map. I didn't do that. I'm figuring this out as I go. You're along for the ride. Or you can go. It's all right. I am going to learn how to solder though. I am. It just hasn't happened yet. I haven't seen a reason to do it since I change it so much. I change everything I do so much, man. I have a shed full of, experiments that I've done. I have like 15 boxes of coils. you know. I just can't. Maybe it's because I can't make up my mind, you know. Usually, when I make it the first time, I make it the best way, and that's usually how it is. And then I change it all up, and it gets worse and worse and worse. But you know, I gotta do it anyway because you know suggestions. People say this, this, and this, and I try it. I literally do. I try a lot of the things that people suggest that I do, and 15% of the time it works out because we're speaking the same language. But as you can tell, I don't speak electronic. You know, I don't. I struggle to say the word diode. You know, I don't speak electronic. I just understand how a circuit works. I'm not trying to change that basic principle at all. I'm not. But I don't know. I mean, uh, it's been likened unto, you know, Jimi Hendrix and the way he learned how to play the guitar. You know, electronics. This is the way I learned how to do it. And exactly the opposite. Everybody else learned how to do it. You know, people would like wouldn't even get involved with doing it before they learned how to solder. You know, it's like I did. And I actually built a rotor for this with a little hole in the center of one of the pegs for a Hall effect sensor. I actually was trying to. I have Hall effect sensors all up and down my little shelf over there. I was trying to get it to work, but like Hall effect sensor is a myth to me, man. It's like hard for me to hook a Hall effect sensor up. And I think it's because you need a power source to make it work. And that right there just turned me off from the get go. Doesn't matter what voltage the power supply is. I don't care. I gotta use power to make it work. It just bugs me. But yeah, 9 volt battery is enough to make that work. But yeah, you gotta find a place to put the 9 volt. Yeah, it's just a whole different way to build it. And I don't know. I was willing a while ago, and then I just the trigger strand works so well. Mm. All right, I'm gonna give it a crown. All right, one go round. Here we go. Got some resonance. Wow, that's hard to stop, dude. It's awesome. See, but everything wasn't flying around that perfect way to solve the problem. And as you can see, no harm to functionality whatsoever. It might be conductive, but duct tape fixes everything. Yeah, you might be right. And it's none of that. None of that. I just don't speak your language. None of that shit. What I know for a fact is that this thing will kind of rotate every single time I turn it on. This is a law that people have ignored. All you need to do is make it so everything can spin and it will freaking kind of rotate every time. Whew! That moves very nicely. I've been up for 48 hours, man. So why don't you go reassess the situation? I see harmony. I see freedom. I see a lack of control that none of you can handle. That's what I see. Let's check this out. Well, there might be some people out there that can handle not being in control and being a scientist of sorts, but I don't know. All right, let's see. 2.67 volts at 10 farad, so that's not bad. So cool. Yeah, man, I'm really tired. I'm reacting poorly to the BS. It's great that you, I don't know, but it's like, so what I see is that because both MPNs are fired by trigger strands, right? That when the coil, this is the coil in question, when it reaches about right there on the magnet, it's going to push. And when it pushes, when it activates, it's destined to counter rotate already. Now, reed switch, same thing. The only thing that might not counter rotate is a Hall effect sensor, but I'm dying to try that. I'm pretty sure it'll work. You just have to line it up with, not perfectly. You got to line it up off center. So when you spin it real quick, see, it's lensing. It needs a little bit of help. Yeah, I bet this thing could get going really freaking fast. And it's only got it's hooked up to 4 coils. But it's like 2 circuits in 180s. So, and 180 is what makes this whole thing work. The 180 connection. Because there's 180 perms, 3 times a rotation, right? 180 perms. And then you got 2 180 coils on off. They're on off. So when one hits, the other's off. When the other hits, the other's off. I don't ponder it. I just accept it. Oh man, because I don't know. And freedom. I said this is you're looking at freedom because of the lack of control. You are never truly free until you let go. I mean, just looking at this thing has taught me stuff, you know? What does that mean, even? You know, you're never truly free until you let go. Yeah, when you're meticulously trying to control something that you can't, go ahead and build it a different way, man. Then you can control it. Go ahead. I'm not stopping you. Put an Arduino in there and soup it up, man. I'm not stopping you. Yeah, man. To be truly free is to admit that you're powerless to do anything about what's going on here. This does it itself, man. Counter rotation is a thing without you even trying. You just have to make it so they can both spin, and they're going to both spin in opposite directions every time. They might need a little push because of certain electrical effects like lensing or resonance. Push it right past that. You see it happen. And even if I did get an RF remote so that I could turn it on and off, turn the power on and off with a remote, it would still be very uncontrolled. It's not scientific. Okay, I'm not trying to brush people up with the scientific method, man. I'm not trying to control this. I'm just trying to experience it. I'm not a real big dreamer, man. People that dream about time travel and all that crap, they love this stuff. I don't know, one way or another, whether it's going to time travel me anywhere or do anything in my head or whatever the frick is going on with it, man. I I don't believe in that. I don't believe that it's morally wrong. You go back in time, you fart next to this guy, and he moves away because it stinks, right? He moves away, but he now has moved into the path of an oncoming vehicle, and that was your best friend's grandfather. So now your best friend never existed. But when you go back, you're the only person that's going to know that. And everybody that you know will not know you. That's the price. I mean, there's got to be a cost, right? Can't just do whatever you want. But see, this is the part, man. You can't do whatever you want, but anybody can do whatever they want to you. And you have to live with that. Why? Because you don't believe in beating the crap out of people. That's why. So people take advantage of that. Take advantage of the fact that you don't want to hurt other people. So they hurt you because they know you're not going to do anything back to them. And that's a real pussy way to live. To pick on people that like peace. That's I'm sorry, but that's very gay. And I don't mean homosexual, man. It's like I apologize. Spoke. And I'm talking like Alexander the Great. I'm gonna murder Egypt, kind of. Just. Uh. But I mean, honestly, for topic of conversation, if we were to go back in time, how far back would you go, and what would you do when you got there? And I'm just like anybody else, I'll fantasize about beating people up all the time, but do I actually ever really plan on doing anything like that? No, it's just anger that you have to process. It doesn't go away, okay? It has to be processed. Just like electricity in a super cap, it has to be processed or it stays in the cap. Yeah, just like human emotions are the same way, man. I've seen people that were like, the calm, mellow type. Wait till they reach 45. No way, dude. Just be prepared for a nuclear explosion. And I'm talking about people that got, pooped on their whole life and they were calm about it. And I mean, I keep on pondering, what Nikola Tesla actually felt like on his deathbed with the US government ripping him off. How did he feel about that? And he probably knew he couldn't do anything about it. He probably honestly agreed to give most of his information to them. Not all of it. No, man. No, that is a miserable existence to die like that. No. Terrible. And I like it, man. I like how he went to the hotel because of the generator in the basement that's allowed him to continue to do his experiments on and off. It's one of those, man, yeah, no kidding. Mm. It's not like he didn't see it coming. He was a genius. But how would you feel? I mean, you're totally powerless to do anything about it. He understands. He understood the freedom in it. You really think they actually waited for him to die? And you know who I'm talking about. Wow, what a tirade. I gotta check. Yeah. He always knew, but it's not like he agreed. It's not like he agreed. You can know and not agree. This is a counter-rotating DC brushless motor. It's run on trigger strands and MPNs. Two equivalent MPN circuits. Now see, this doesn't have to rotate this part. The real magic of this is having the electromagnetic rotor. See, this is another stator. This one doesn't spin. As you can see, the hole won't fit a bearing in there, so this one's stationary. So when you look at somebody else's motor, pulse motor, look at how it's built. If they got the electromagnetic coils on the rotor, but if it's a rotor like this, it's not the same thing, and it doesn't work the same way. I mean, it does work the same way, but the outcome is different. But what would be really cool, maybe, is to hook this rotor up and have coils on something like this, just to see. I mean, I haven't built one like that yet. That would be pretty neat, I think. Would it react the same way? Would it counter rotate every time? Look at that stator go. Man, it's still moving. Yeah, to put electromagnetic coils on the stator. And it was still going. Probably would have lasted about another minute. All right, so Maybe you can hear that. Not sure. Wow, man. All right, I'm gonna run it like 3 more times, and then I'm gonna test it again and see if we're up to like 3 volts or not. All right, so the X pattern, the series connection of the two, well, there's 2 bifilers in each circuit, and they're at 180 degrees. And let me think here. This is the beginning of one, and this is the beginning of the other. So whenever one's hitting, one's off. Whenever the other one's hitting, the other one's off. So we could call it the 0-1 on off. All right. I'm gonna have to hit this sack after I'm done with this. So sorry for not engaging. Well, I think I did an all right job with engaging. All right. Oh, it went up 2.79, and it just went up when I turned it on. So probably just at the very threshold there. So it looks like for how much energy we're producing less each time we turn it on, which might be legit if the battery is depleting like that. I don't think it is though. I'm in the zone. I apologize. Let's see what's going on here. Sure. Yeah. It is gyroscopic. I appreciate everybody's input. I hope I was tolerable tonight. Have a good night, everybody. Peace out.